So now some more specifics on alcohols. So we're going to talk about generalized formula and how to recognize our alcohol group. So any organic compound that has an OH group is considered an alcohol. And we're going to focus on alcohols that are part of saturated. That alcohol must be attached to a saturated carbon atom, meaning that carbon atom must be attached to 4 different atoms total, or 4 atoms total. So the general structure is considered ROH. R is just a generic placeholder for a hydrocarbon. So that could be any carbon chain, whether it's just 1 carbon, 10 carbons, 50 carbons, whatever. So the OH functional group we also call a hydroxyl group, alcohol group. Either one would be considered okay. So here's a couple examples. We have OH attached to a methyl. Here we have OH attached to C3. This should be CH3. There's an H missing here. CH3CH2, so 2 carbon chain. Alcohol is not the same as an OH group from an ionic compound. So this group is hydroxide, which we've talked about, with a -1 charge. An alcohol group is not the same thing. For one, alcohols are only going to be found in covalent hydrocarbon molecules, not in ionic. So make sure you notice the difference between those 2 OH groups. Alcohols are in a lot of ways similar to water when we think about them structurally. So water, we have the oxygen atom in the middle attached to the 2 hydrogen atoms, and the bond angle here ends up being about 105 degrees. For the alcohol, we have the oxygen, again attached to a hydrogen atom, but then the other side, instead of hydrogen, is a carbon chain. Here the bond angle is a little bit bigger, and that's because this carbon, and however many other carbons it's attached to, takes up a little bit more space. So these hydrogens kind of butt up against each other, which pushes them away, making that bond angle a little bit bigger. So if we look at these structures, which of them represents an alcohol? So remember, we have to have an OH group attached to a saturated carbon. So if we look at this first example, the O and the H are not attached to each other, so that one we can quickly eliminate. The second example, again, the oxygen does not have a hydrogen attached to it. C and D, both of these have an OH group. The difference is the carbon that it's attached to. So in this case, the carbon is attached to 3 other atoms, which means it's saturated, versus D, where the carbon is attached to only 2 other groups, which means it is not saturated. So C is our answer. It is an alcohol. D is not an alcohol.